Hey, it's Mr. Shrum, and I am back again with the tutorial walkthrough for the circulatory system. And today we're going to look at the heartbeat. The heart contains an internal conduction system, and this internal conduction system sends electrical impulses through the heart, and that results in a contraction of the muscles in the heart. The contraction of the heart creates a heartbeat or cardiac cycle. These are the components of the system, and we'll look at each of those right now. The sinoatrial, or the SA node, is a group of specialized myocardial cells that spontaneously generate electrical impulses within the heart. It's known as the pacemaker of the heart because it initiates the cardiac cycle. The SA node is located near the top of the right atrium. And about 70 times per minute, the SA node initiates the electrical impulse that causes both atria to contract. There is a band of non-conducting tissue that separates the atria and ventricles. Therefore, the impulses that causes the atria to contract does not spread directly to the ventricles. The electrical impulse wave then reaches the AV node. The AV node is located at the base of the right atrium. There's a slight delay that allows the blood to empty from the atria into the ventricles. The AV node then spreads the electrical impulse to both ventricles through the AV bundle, the right and left bundle branches, and the Purkinje fibers. Together, they cause both ventricles to contract, squeezing the blood out of the heart to either the lungs to be oxygenated or to the body to oxygenate the rest of the body. And there are 3 stages of the cardiac cycle. The first stage is when the SA node causes the atria to contract. The second stage is when the AV node, the AV bundle, and the Purkinje fibers cause the ventricles to contract. So first, the atria are contracting, then the ventricles are contracting, and then the third stage is when both the ventricles are relaxed and fill with blood. The contraction of the heart muscle is known as systole. The dilation of the heart muscle, otherwise known as when it relaxes and fills with blood, is known as diastole. You can listen to your heartbeat using a stethoscope. That is a device that amplifies the sound within the body, such as a heartbeat. The heart sounds like lub-dub, and the lub, that first sound, comes from the closure of the AV valves. The dup, the second sound you hear, is from the closure of the SLV valves. You can also feel the heartbeat. When the left ventricle contracts and causes the elastic walls of the arteries to bulge and then recoil, this alternating bulging and recoiling of arteries is known as your pulse. The pulse rate indicates the speed in which the heart is beating. You can easily feel your pulse at the radial artery along the lateral side of your wrist near the base of your thumb, or the carotid artery along the lateral side of your larynx near the base of your jaw. So radial artery near your hand, wrist, carotid artery near the base of your jaw. You can see the heartbeat by looking at an electrocardiogram, or ECG, sometimes EKG. And that is a recording of the electrical activity in your heart. And there are waves to look for. The P wave is the first wave, and it represents the contraction of the atria. The QRS wave is the second wave that occurs during the contraction of the ventricles. The T wave is the third wave, and that's caused by the recovery of the ventricles. And arrhythmia is when the organized pattern of the cardiac cycle is disrupted. So something's going on and it's not quite right. That can occur because the electrical activity of the heart is too slow, too fast, or just not following a pattern. So for example, ventricular fibrillation is when the electrical impulses to the ventricles are disorganized. And that results in the ventricles not being able to properly propel blood out of your heart. Ventricular fibrillation can be life-threatening. So in order to treat that, a defibrillator is used. This works by sending an electrical shock to the heart that causes it to depolarize, which then allows the SA node to resume control. Heart rate is influenced by sympathetic nerve fibers that stimulate the SA node, parasympathetic nerve fibers that inhibit the SA node, and the hormone epinephrine stimulates the SA node. Blood pressure is the pressure exerted on the walls of arteries, and it's the driving force behind the blood flow in your body. Systolic blood pressure, or SBP, is the pressure that blood exerts against the walls of the arteries when the heart is contracting, so systole. The normal range for systolic pressure at rest is 90 to 130. So if you've ever gone to the doctor to take your blood pressure, or you have a parent or guardian that needs to check their blood pressure all the time, maybe you're more familiar with this number. Diastolic blood pressure, DBP, is the pressure that blood exerts against the walls of the arteries when the heart is relaxing, diastole. And that range for diastolic pressure at rest is between 50 and 90. So those are the numbers you should aim to have your blood pressure between for systolic and diastolic. And the way it's recorded is as a fraction. So it's systolic blood pressure over diastolic blood pressure. So a normal blood pressure would be read as 120 over 80. To measure blood pressure, a sphygmometer and stethoscope are needed. So a sphygmomanometer is made of an inflatable bag known as the cuff, an inflating bulb, and a meter that allows the pressure to be read, as well as a valve to deflate the system. Let me hear that read out loud.
Sphygmomanometer is made of an
Sphygmomanometer. That's a lot of syllables for that word. So practice saying that word a lot. And your heart is a really interesting muscle. It continuously pumps blood to your lungs and to your body. You need your heart to live, and that's why it's so important to keep your heart healthy and strong. Heart healthy behaviors include being physically active, eating a healthy diet, maintaining healthy cholesterol levels, not smoking, and monitoring blood sugar levels. So that's it for the heartbeat lesson. And next time we're going to look at the issues that can result from the heart not behaving in the right way. So, but we'll get to that next time. Until then, have a great day. And if you have any questions, message me, and I will see you all later. Bye.